Let's jump right into this explainer, because today we are unpacking a truly fascinating new paper that maps out the future of modern medicine. When we hear about AI and robotics in the operating room, it is so easy for our minds to instantly jump to some dystopian sci-fi movie where cold, autonomous machines just entirely replace human doctors. But honestly, based on this comprehensive analysis, that is not what's happening at all. Instead, we're looking at a massive, systemic upgrade to the entire surgical ecosystem. We're talking about a fundamental shift in how human teams and smart machines collaborate.
To really wrap our heads around why this revolution is even necessary, we have to look at the staggering scale of the problem. Surgery handles about 30% of the global disease burden. 30%! Yet right now, there's an absolutely massive gap of over 143.1 million unmet surgical procedures annually across the globe. That's a mind-blowing number. We simply don't have the human bandwidth or the efficiency to meet that kind of demand using traditional methods alone. We desperately need a paradigm shift, not just to perform better surgeries, but to make high-quality, precise surgical care vastly more scalable and accessible to everyone.
So let's break this down. Section 1. AI as surgical co-pilots, the data revolution.
Okay, so how do we actually go about solving this massive global burden? Well, it starts with the first pillar of the revolution outlined in the source material, treating the operating room not just as a physical space, but as a highly sensorized, intelligent data ecosystem. We are officially entering the era of the AI surgical co-pilot. Think about how a continuous flow of data is going to power these new systems. We aren't just talking about a high-def camera looking at an organ. The future OR will holistically integrate data across your entire journey as a patient. Preoperative biomarkers and imaging feed into the system long before you even enter the room. Then, during the surgery, the AI is pulling in video, listening to audio of the team's communication, monitoring physiological stress signals from the surgeons themselves, and tracking the exact kinematics of the robots. It's essentially an ambient intelligence acting as a flight data recorder, complete with near-miss warning capabilities, seamlessly supporting human decisions in real time. And all this complex, overlapping data powers an incredibly exciting concept that the authors are calling causal surgery. Now, current AI often just looks for patterns or simple correlations, but causal AI, it goes much, much further. It creates counterfactuals. Basically, it allows the system to answer complex what-if questions right there on the spot. Like, what if the surgeon cuts at this specific angle instead of that one? The AI can predict the absolute best, highly personalized intervention for your specific anatomy. It effectively shifts surgery from a reactive process into a highly predictive, prescriptive one. It's a real game changer.
Moving right along, let's hit Section 2, the next-gen robotic OR, from passive tools to agents.
Let's shift over to the physical realm, because all that incredible data has to actually be translated into physical action, right? And that completely redefines what a surgical robot even is. For decades, surgical robots have basically been highly precise but entirely passive tools. It's a master-slave dynamic where the robot only moves exactly when and exactly how the surgeon's hands move. But now, robots are being equipped with what's called embodied AI. This means they use multimodal sensors, force, pressure, optical, proximity sensors, to actually perceive the room. They have situational awareness. They can anticipate a human's movements, avoid collisions, and adapt on the fly. They aren't just tools anymore. They're becoming aware, active agents in the room with you. So think of the operating room not just as a static location, but as a continuous, perfectly automated pipeline. Before the patient even rolls in, robotic systems will autonomously drape the surgical field and map out the spatial coordinates of the room. During the operation, intelligent robotic scrub assistants will track tools, hand off instruments, and even perform task-specific autonomy, like suturing or steering the camera. And once the surgery is over, a literal fleet of automated logistics and UV sterilization bots move in to clean and prep the room for the very next case. It's this unbroken, highly efficient chain. Just picture the sheer choreography happening in the future OR. You've got the human surgeon orchestrating the entire procedure from a high-tech console, while a robotic scrub assistant autonomously manages the instrument trays right at the bedside. You've got emergency response robots on standby equipped for automated CPR, and logistics bots running supplies in the background. Every single element is connected, and every robot is working in perfect tandem, all under watchful human oversight. Which brings us to Section 3, Evolving the Surgical Team, the Human Shift. To me, this is hands down the most fascinating paradigm shift of the entire paper. What happens to the humans? The entire culture and dynamic of the surgical team is about to be completely rewritten. Traditionally, the surgeon acts alone,
physically at the bedside, operating as the sole, ultimate decision-maker, relying purely on their own human senses. But the future surgeon, they become an orchestrator. They are shifting from pure physical execution to high-level strategic coordination. They'll be overseeing multi-robot workflows, selecting the right levels of autonomy for different tasks, interpreting AI data on the fly, and jumping in physically only when human intuition and expertise are strictly necessary.
And to support this incredible cyber-physical ecosystem, brand new team members are going to have to enter the fold. Traditional roles will definitely evolve, like scrub nurses will likely shift to supervising those automated robotic assistants. But we are also going to see entirely new professions popping up in the OR. Clinical data scientists will be there to manage the real-time AI outputs. Robotics integration engineers will make sure the complex network of autonomous machines in the hospital's IT infrastructure actually talk to each other without crashing. The whole team becomes highly interdisciplinary.
Okay, let's take a beat. This all sounds incredible, super efficient, and honestly a little bit like the future has already arrived. But it forces us to ask what is arguably the absolute hardest question in modern medicine. When a highly advanced AI recommends a specific cut or an autonomous robot is handing off a tool and a critical error occurs during surgery, who is liable? Seriously, who is in charge? Is it the surgeon, the software developer who wrote the code, the hospital's data scientist? And that sobering reality check leads us perfectly into Section 4, Ethics, Equity, and Regulation.
Look, the technology is accelerating at a breakneck pace, but as the authors detail, we have to tackle the extremely practical, unresolved issues of legal liability, algorithm bias, and global healthcare equity before these systems can be safely rolled out everywhere. Think about it. If an AI model is trained exclusively on surgical data from a specific homogeneous demographic and a few wealthy hospitals, it is going to mathematically underperform when applied to a generalized, diverse population. It risks actually making health inequalities worse. That makes strategies like federated learning, where decentralized global institutions collaboratively train models without ever exposing raw patient data, absolutely mandatory. We have to ensure the AI knows how to operate safely on literally everyone, not just the populations it was initially tested on. We also have to face the stark contrast in global health equity. Without what the authors term frugal innovation, basically creating cost-effective AI solutions, lower-income regions face some severe risks. They might be entirely excluded from these massive advancements, or, even worse, they could be subjected to ethics dumping, where experimental technologies get tested in areas with weaker regulations. Meanwhile, all the advanced, polished tech could just concentrate in elite, wealthy hospitals, which would widen the global healthcare divide rather than closing that massive 143.1 million procedure gap we talked about at the very beginning.
So how do we navigate all of this? Ultimately, to ensure these immensely powerful tools sustain human care rather than disrupt it, the authors conclude that future ORs absolutely must remain a strict human-in-the-loop paradigm. And this isn't just about patient safety, it's about maintaining a crystal-clear chain of command for liability. The AI models will generate options, complete with probability scores, but the human surgeon must actively select, modify, and execute the final decision. The human element just cannot be removed from the equation.
As we stand on the threshold of this wild medical revolution, where AI is acting as your surgeon's hyper-intelligent co-pilot and robots are actively perceiving the room around them, it really changes everything about how we view a trip to the hospital. So, I want to leave you with this final thought to chew on. When you are the one lying on that operating table,